Hey folks, how you guys doing today? Let's see, just fade that out nice and slow. There we go. Alrighty. So I hope you guys are having a good day. So I just realized I forgot to upload this stuff for you. Apologies. I've got all of the textbook slides hopefully showing up here any second now. We're almost done. I meant to have those and I'm sorry. I should have copied those over for you sooner. So, but happy Thursday. Let's see, it's been going relatively well. Had like one little blip earlier this afternoon with Comcast, but other than that, pretty stable. So hopefully it's going well. Although, of course, now I can't see anything. There we go. I just had to refresh. All right, sweet. Oh, of course, they're out of order. We do that? No, that's not it. That's fine. Here we go. So refresh that. We should all be here. Boom. All right, I just need to move them around. Sorry. It bothers the OCD-ness part of me if they don't upload or if they're not in the right order. Hopefully that's okay. All right. There we go. Move a couple of these. You know, I can zoom it out. Oh, that might make this easier. There we go. 4. A little more. 5. Yeah, there we go. A good zoom level. I don't have to scroll. 6 and 7. Almost there. 8 and 9. All right, awesome. So those are out there for you guys for reference. Again, don't share them outside of Desire to Learn, please. There's a copyright notice on the tail end of them, the last slide. So, you know, let's respect that. So I don't put those publicly out there. So a couple things to note. The Chapter 6 and 7 quiz, don't forget, is due by 11:59 p.m. tomorrow. So I did push it out an extra day. I didn't have it up for you right away or turned on everything in D2L till real late. So I wanted to make sure you had at least a week for that. It is open book, open notes, not open neighbor. Okay, so use your resources. That's fine. You can start the quiz. You can come out of the quiz. You can go back to it. You can open it up anytime until it's due. Oh dear, dropping stuff. There's a quick dinner here and it's falling all over me now. But I do have my coffee. That's good. All right, so we have on tap for tonight the first half of Chapter 8, our second look at classes. Let's take a peek here. Our schedule. And it's on the last page. There we go. So we'll talk about that tonight. We'll get not quite halfway through Chapter 8, maybe about halfway through Chapter 8. And then next week we'll finish up Chapter 8 and we'll talk about the second project, using some more of these interesting features of classes and objects that we'll talk about. So for Project 1, we went over that last week. Any other questions about Project 1 and unit testing before we jump into stuff on Chapter 8? I'll pause for a minute here. See if anyone has anything in chat. I'm just going to close that. Cool. I actually had 2 people already submit. Oh, so for you guys, I do apologize. I forgot to change the default setting in D2L. D2L expects everything as a file upload, and you would send stuff into D2L for grading. And once someone submits, I can't change it. It's locked. So just upload any file you want. Someone found a funny picture on Reddit of a squirrel or something like that. I forget. So they added that one for me. So that's awesome. So any file you want, but still give me the URL to your GitHub code, and then we'll be in good shape. Okay, I had 1 vote for good. No one voted for talking about it again. That's fine. It's a good sign. So let's fire up NetBeans here. Testing, yeah. So the idea with testing is we are with code saying I expect this behavior. So if I know what the method is supposed to do, Project 1 is due on the 4th. Yeah, 6 p.m. on the 4th, because I will go over the solution at 6 p.m. for you guys. It should be the 4th. Did I screw it up? Let's take a peek. It should be the 4th at 6 p.m. Let's see. Yeah, the 4th at 6 p.m. Yep, the 4th. We're good there. So I got a couple more project zeros to grade as well. I'll get those ones checked out for you guys too. Oh, so project 2, we're going to assign that day. Sorry, I don't have due dates in the syllabus. I have like, this is when the project is assigned in the syllabus. Sorry if that's not clear. All right, so we're done with that class for now. Close the project. And let's open up a new one. Yes, yeah, so next week after we finish chapter 8, we'll talk about the second project as well. So typically, you'll have a project every 2 weeks until we get to that final project. Here, you know, let's open up that existing project. So we'll look at the testing here again. 2151. I gotta clean out my GitHub there. So we did the night review for chapter 6. Is that it? I think that's what we did. Yeah, I'll try that. Trying to keep all this straight for you guys. That's what we did vehicle. Okay, so the idea with unit testing is that we know what vehicle is supposed to do. So if I were to go and add gas, it first will make sure that I'm adding a positive amount of gas. I'm not actually going to remove gas somehow by calling add gas, giving it negative. So I know that's one behavior. So that's one thing I want to test. So in my test here, I'm going to go to vehicle test, and I'm going to test add gas with a negative value. So you want to name your test methods something meaningful and useful. So in this case, I'm going to put, I say I should have 0 gallons in the tank. That's what I expect to have happen. Sorry, I've got no idea. That's I've never been to the state of Washington before. I'm sure they're all good. So this is what we expect. So we're arranging, this is the things we need to do our test. Then the code we're actually using that we're testing here. We make a vehicle. It has a capacity of up to 5. If I try and add a negative amount of gas, we'll see what the vehicle class tells me I actually have in the tank. That's my actual value. And I'm going to say, hey, they should match. And because they're doubles, I need this delta, as long as they're close enough, right? Because Java's bad at math. And then my results should be, I should have gotten back a false. We're going to say this should be false because I know what vehicle is supposed to do. So this has given me some confidence, if that test passes, that I probably did it right. You're not 100%, but you should feel better about it. Then, right, so that's the one case. Now, if we give it a positive number, we're going to add to the tank. And then if we went over the capacity, we stop at the capacity. So we just pretend we stopped, and then we still return a false. Again, we'll worry about exceptions later. We're just saying, oh, something bad happened, false. It didn't work like you expected, just FYI. So we'll come back to our vehicle test, and here's our regular adding over capacity. So I expect to have 2 gallons in the tank if my capacity is 2 gallons, and I try and add 4.2 gallons of gas. So I should get back, this should be a false. I'm going to assert that's false. This assert equals is silly. Like, don't say false equals that, right? This is redundant. Redundant? I forget. Okay, so we'll just say, hey, I should have got back a false result, and then what's actually in the tank should be 2 within a certain delta again. So I'm testing that case. So now I feel pretty good that if I go over capacity, I get back a false, and I stop at the actual capacity. Other than that, I want to make sure I do get a true value back out. So I got one last test here then, just regular adding gas. If I have a capacity of 5 and I add 4.2, it should have told me true, and the actual gas in the tank should be 4.2. Again, with the delta. That makes sense for the test? So what we're doing then with project 1 is we're going to do the exact same thing with tests, where I know what the plane should do. Right? This is how it should behave, so I can put that into a test. We'll say, hey, if my altitude is, if we're trying to change altitude, we give a positive or negative number. If we're above max altitude in feet, we should probably stop at max altitude in feet. Right? Don't let it go higher than that. Also, don't let it go below 1,000 if the landing gear is enabled. So if landing gear is on, don't be able to take a negative number and go below 1,000. Right? Stop at 1,000. So we can write tests to say, I expect this behavior to happen because I know what it's supposed to do. Let's make Java check it for us. Now I don't have to do everything in main. And then for enable landing gear and disable landing gear, check your altitudes, right? If my altitude is greater than 1,000, it should not enable. If it's less than 1,000, it should enable. Right? If I'm less than 1,000, it should not disable. If I'm more than 1,000, right, I should be able to disable it. Or I guess right at 1,000. I mean, it probably shouldn't be at any higher than 1,000 if the landing gear is still there. I guess that's, no, I guess you're just supposed to change it. Sure. Does that make sense, what we're trying to do with this then? Okay, cool. All right, so let me close that project down. We'll start a new project. Make sure I put this in the right folder. 51 is chapter 8, night class. All right. Cool. Let's start a new package. I'm just going to add another class. Let's just add a quick class here. We'll call this, what do we want to talk about? How about math fun? So what I can do with a class here, so let's talk about vehicle again real quick. When you had a vehicle, right, you had an instance of vehicle, and that instance had its own set of values, the make, the model, and the color, along with its gas and that sort of thing. And you can make as many instances as you want. You can also make static methods that you don't require an instance. So for doing some math, we could calculate certain values here. And again, Java has a math library. We're just doing this as an illustration here, that I don't need an instance of math fun to do these calculations because I just know what these values are. So I'm going to say I've got a public static final double. We'll call this pi approximate, like 3.14159 something, right? On and on and on. So this is a static field, and I've marked it as final because I'm going to set it one time and I'm not going to change it. So if you want to use this pi approximate value from in here, we would say I want math fun dot math fun, sorry, dot pi approximate. Again, the math library has its own pi value, but whatever here. So we can get at it through the class name dot attribute because it's a static field. So I don't need it to make an instance of math fun. I don't need, say, math fun, my math fun equals the new math fun. I don't need to call a constructor. I don't need to make an instance of it. I don't need to do anything now with my math fun. Right? There's actually nothing here on my instance. So these are the object versions, right? Because we inherit from object eventually. Think back to 1500 when you talked about inheritance. So there is no pi approximate here at the instance level because it's defined at the class level. It's static. So we say math fun dot. And you get at the static variables and methods. Okay? So we don't need this. We don't need an instance to do anything. Right, and then other things we can do, right, with math, we could calculate, say, the area of a circle. So a public static double get area or something. I don't know. Or calculate area. Calculate area given a double for radius. Right, if you give me a radius, I'll be able to calculate your area. Right, that's pi approximate times radius times radius. Right, pi r squared should be the area of a circle. Or I guess I should say of circle. Circle. Sure. Calculate area of circle given a radius. That's a static method. So if I have a radius value, I can go get the circumference out. So double circumference, or no, the area is math fun dot calculate area of circle and say, hey, maybe a radius of 5. And then sure, maybe we'll just print the area. Area. So just like the other math functions we've used before, or double.parseDouble, and we've used the static methods before, you don't need to have an instance of math fun in memory because it doesn't have any instance variables anyway. Right? So these are static methods and static fields. So they're defined at the class level and shared among, the whole class, that sort of thing. And maybe we ask for a value, sure. So let's say enter a radius, and I'll tell you the area. And then maybe we'll use scanner for this. So scanner is not static. Right? We call this constructor, and this instance of scanner then is pointed at the the standard system input, the keyboard. You can use scanner for other things when we get to working with files. Hopefully you did this back in 1500, but we did a quick little bit on files. You can point scanner at a file, and it'll open it up and read it for you. That's a different instance. Right, so each instance needs to track what it's accessing. So then we'll say, I don't know, radius, double radius equals, and I always prefer using double.parseDouble instead of keyboard.nextDouble. Remember, if you don't use next line, use like a next int or a next double or next float or whatever, it doesn't get the enter key off the buffer, which is obnoxious. And then you have to go get next line anyway to get that enter key off, or clear it out, or flush it, or whatever things you have to do. Right? And really, we don't even have to save it as a variable area. We can just throw this right in here, which is kind of fun. Save yourself a line. Right? You saved one whole line of code. Don't you feel good? Right? So maybe we'll say the area is plus that. Let's try it. Drink some coffee while it builds. Oh man, okay. I gotta go to my project properties and tell it to not compile on save, because that does weird things, and I still don't understand why. But sure. Excuse me. All right, enter a radius. I'll tell you the area. How about 5? So if our radius is 5, pi times 5 squared, 5 times 3.14 times 25. That sounds about right. Okay, so it's using static methods of a class. Right? Other things you can do, and sometimes this is useful, other times it's just awkward. We might have a static value, public static, I don't know, counter. Oh, that's an int, sorry. Public static int counter is 0. And what we're going to do is every time we call a method, we're going to take counter plus plus. So there's a static, so a class level variable that's accessible and can be modified inside of any other static instance, any other static method. We can get at it here. This value is shared among all math fun at the class level. And you should be able to get it from instance values as well, which is fun. So then if I wanted, I could output here like how many times I've calculated radius or used my math as fun. Again, this is very contrived, but we could if we wanted. So let's print you used math fun, and let's add in there math fun dot counter times. So really this is only useful like, I mean, sure, we'll use it one time, but we could put it in a loop and see how many times we looped through. Yeah, we used it one time. And if we did it more than once, right, if we calculated twice, or 3 times, let me format that, we should get 3, right? Because every time we call it, it should run. There we go, we used it 3 times. Again, not the most interesting use of that field, but you can do some stuff with it. Sometimes you can do fun things with it. Okay. Okay, maybe a more interesting example. Let's make another class here, like bank account. Okay. and bank account, then we'll do a couple things. So we're going to have a private string for owner name, right, whose bank account it is, a private string for account type, maybe a private double for balance. Okay, so you know who owns it, you know what their account type, like checking or savings or something or other, and the balance. And then we probably also have an int for account number. Again, in the real world, it's probably not an integer value because you might have leading zeros or other things that could mess this up, and you probably just want to deal with it as a string, but that's going to mess up our system here. So these are instance fields. We're also going to add a private static int for current account number. We're going to start that one off at 1. So at the class level, we'll have a current account number. And we're going to make this private. I don't want other people to have access to that outside the class. But inside the class, I'm going to be able to use it. So we'll write a constructor, bank account, and we'll take maybe a string for owner name. Maybe we'll take a string for account type. Okay. The constructor's job is to set values to all the instance fields. Right. So this dot owner name is the owner name, and this dot account type is the account type. Oops, not number. Sorry, I want type. And then my this dot account number should be my current account number. And then this dot balance. I mean, actually, this is silly at this point. I don't need it. It just kind of makes it symmetrical. We'll start off with $0. Then what I want to do is I want to take the current account number. I want to add to it. Add 1 to it. So this will increment that class level static value. So each account that I create using constructor will get the next number. So I'll get 1, and then 2, and then 3, and then 4, and then 5, and 6, and as many as I make, they will each have a unique account number because they're all sharing access to this current account number. Again, in the real world, this would probably be linked to some sort of database that would generate the numbers, because like every time your code runs, it restarts at 1. So that's not ideal. I mean, but it's just an example here. Okay. Then what I want to do, right? Don't do more work than you need to. I'm going to go to insert code, right-click insert code, and insert my getters. I'll get the account number, get the account type, get the balance, get the current account number. No, I don't want get current account number. That's my static value. And then I want the owner name. Okay, so get owner name, get account type, get balance, get account number. Those are the instance fields, right? For each instance of bank account. Great. We got those. And it's telling me, hey, I could make them final if I wanted. Some of them could be final. Balance should not be, but sure, why not? Final string owner name, final string account type, and final int account number. I'm going to move balance down just because it doesn't fit the... Oh, it seems silly to have that in the middle of that. Just for fun. Okay, so we set those once, they're final, we can't change them. That's fine, right? You probably close the account before you can change the owner. I don't know. And we made up the code, it's our rule. So we have gets for all this. Then we need to have certain behavior for changing balance. I don't want a set balance method. If you run a bank, you don't want people to have public access to set their own balance, right? You want them to initiate a deposit or initiate a withdrawal. And they have to go through the logic there of deposit or withdraw. A dad joke. Yes, you guys got it. So, not in the winter as often because, you know, pipes freeze and whatnot, but I do like to wash my car. And I was washing it with my son the other day, you know, back in the fall, and he wondered why I wouldn't just use a sponge. So we're going to have a public boolean we'll call a deposit here. A double, I don't know, amount to deposit. Right? So the first thing we want to check, right, is making sure we're depositing a positive number, right? So they're not actually giving a bad value here. So if amount to deposit is less than or equal to 0, let's return false. That's no good, bad, it's just we're not going to do it. Okay? Now, technically you could put an else here, but it's redundant because if you hit return, the code stops. So I don't need to do that. I'm going to hit a quick format here. Otherwise, I'm going to take my balance and I'm going to add to it the amount to deposit. And I'm going to return true. That's it. Right? If it's not negative, sure, I'll add it to your account. Go for it. Maybe you might have something like if amount to deposit is greater than $10,000, right, 10,000. Let's this out. Alert. Who gets the alert on this? Bank. Investigators. I forget. Investigators. Someone there's some rule. If you deposit 10,000 or more, it gets flagged on a list or something like that. You also, by the way, get flagged very easily if you deposit 9,999 multiple times to avoid this $10,000 limit. I forget what exactly this is, so just forget about that. That's a fun fact. You know, I bet we could even Google that. Bank deposit 10K alert or something. I don't know. I'm sure we'll get a hit here. Currency transaction report to the IRS. There we go. Look at that. They will tell people. Right? They like to know. All right. Sure. We're not going to bother with that in our code. That was just a fun fact. Okay. So deposit. Good. How about withdraw? Boolean withdraw. Double amount to withdraw. Withdraw. Withdraw? English is not my strong suit. I apologize. Okay, so we're going to withdraw money. First, let's make sure it's positive. Right? Don't withdraw negative, because that would actually be like depositing somehow. So if the amount to withdraw is negative, return a false. Or, here, I'm going to do some fancy logic here. Or the amount to withdraw is greater than the balance. Right? If you try and take out a negative amount or more than you have, we're saying, no, denied. Otherwise, take our balance and let's subtract the amount to withdraw, and then we'll return true. True. Okay? And then we'll give that a little format. We all right with that? So this is our business logic, right? This is what we're going to do for deposit and withdrawal, because the only way you can interact with my class is through the public functions. We write a class that encapsulates all the details of a bank account together in one nice unit, and we can interact with it abstractly using its public interface. All the public methods are the only way we can get at these values. If you're a bank, you don't want people to have access to change their balance directly. That's bad news bears, right? You want them to have to go through your system that has all of these checks in place, because a class's job is to maintain its own integrity, right? It should not let people interact with it in a way that puts it in a bad state. Again, we haven't got to exceptions yet, so we're doing booleans because why not? We can make do. All right, so what I want to do now is I want to write some tests. Right, so I want to navigate, go to test. It says, oh, I don't have any. That's fine. Make sure you pick JUnit 4. You will not have much success if you use regular JUnit. And if you do, show me how. After about half an hour, I just gave up on it because I was upset with it. Great. We're going to write some tests. Oh, I forgot. I didn't get the... That's okay. It didn't give me any default ones, but that's all right. So we were going to write some tests from scratch. I think I unchecked the wrong box, those default method bodies. That's all right. So we're going to do a public void test bank account constructor. Why not? And then we need to do this test annotation, the @test, to tell Java, yes, this is a test method here. We're going to arrange, we're going to act, then we're going to assert. Right, so a couple things. We know the bank account constructor needs name and account type. It'll have a balance, it'll have an account number. Sure, why not? So we're going to say, I'm going to have a string for expected owner name equals Eric, a string for expected account type equals, sorry, not Eric again, like checking, and a int, a double, right, for expected account balance is 0, and a int for expected account number is 1. Okay, so let's make it a bank account. Bank account equals a new bank account, and we'll give it bank account. We'll give it the expected owner name. Oops, expected owner name and the expected account type. Now we need to go get these actual values out. So we'll have a string for actual owner name is my account.get owner name. We'll have a string for actual account type. Actual account type is my account.get account type. We'll have a double for actual balance. Account.get balance. And one more of an int for actual account number. Account.get account number. Okay, and then we're going to assert. So we need 4 different asserts. So we'll have assert equals the expected owner name and the actual owner name. Right, I'll do this 4 times. 1 for the actual account type, 1 for the expected account type, 1 for the expected account balance, 1 for the actual account balance. And it's a double, so it's going to need a delta, right? Within, sure, I mean, doesn't matter too much. And then the actual account number and the expected account number. All right, let's run our test. Let's see if it worked. Let's see if our code does what we expect to do. Now, this constructor is kind of boring, but it tests all the gets, so it's good. Okay, that one passed. We're happy so far. Now let's write another one. So let's see. So we tested the constructor. We tested those values, right? We tested the gets. We're in good shape. So now we need deposit and withdraw. And the idea of code coverage, right, is how much of my code is actually running and executing in my tests. If I only test the deposit that works, I don't have 100% code coverage because not all of my code is running. So I need multiple tests. Like pretty much anytime you have an if or an else, you have to have a test that makes sure that that code runs. Make sure that is that right, English? Sure. That code runs. And same with withdrawal. Make sure I hit this and this one runs. Now, technically you'd still have code coverage if I only test this case, but I want to test that both of these will trigger, that either the amount of withdrawal is negative or it's greater than my balance. So I'm going to write 3 tests for withdrawal because I want to make sure every piece of it is actually checked. Because if the code's worth writing, it's worth testing to make sure you did it right. So nat test, this is public void test deposit. Okay, we're going to arrange, we're going to act, and we're going to assert. So I have a double for expected balance. Say like $4.2. Why not? Act, we're going to make a new account. So bank account equals a new bank account. And the name and the type don't actually matter. Right? We don't care. So I'm just going to give them empty strings. Then I'm going to call account.deposit. Give it the expected balance. Okay, and then I'll have a double for actual balance. So the only way I can test if deposit's working is by checking the new balance. So it's sort of, I mean, ideally a unit test tests one thing only, but, you know, we can't test without this, so it's okay. Don't feel too bad. And gets are really boring. They're kind of silly to test anyway. Is account.get balance. Okay, and then we'll assert. Assert equals my expected balance and my actual balance. And with the delta, sure, some number. Let's see if it works. Uh-oh. Oh dear. So this is a different problem, and this is unfortunate. So test bank account constructor. We expected a 1 and got a 2 for what line here? On our expected account number. Because that's a static value, I don't actually have control over which one of these runs first. And apparently this one is not running first. So I'm going to put that as 2, and then I'm going to feel bad about myself, but I'm going to run the tests again. Okay, so now it worked. Again, this is bad and terrible and why static values are just weird anyway, but that's okay. So that's our test deposit. Oh, and then we actually should have a Boolean result, or deposit result, right? Deposit result, because that returns a Boolean, and then we can assert this is true. Assert true, my deposit result. Okay, making sure I did get a true result back. I'm going to copy paste all that. Okay, and we'll test deposit negative value. So now my balance should be 0 if I try and add a negative value. So if I deposit, say, negative 4.2, I should stay at 0, and that should give me back a false. Right? So if I try and deposit a negative number, we said I should get back a false, and the balance shouldn't change. We can run that test. All right, now this account number apparently is 3. This is terrible, I'm sorry. Not a great test, I'm sorry. Okay, and that one passes. So I feel pretty good that deposit works. Right? Hydration, oh, thank you. Let me get some more coffee. And I love thermal mugs that keep the coffee warm. That's awesome. How you guys feeling so far? Okay, cool. If Dogcoin kept going. My friend actually was just texting me. He said Elon Musk was plugging it again. Yeah, my wife has a Yeti mug. This is one I got for Christmas. So we'll see. This is to the moon, I know. Nice. Nice. They are having all sorts of trouble, though. That's unfortunate, but it's okay. Oh, you guys are fun. You guys are fun. All right. So we could do more with bank account testing withdrawal. Let's go for it. We'll test our withdrawals. Why not? So now the problem here, and someone asked me this about the plane class, is that if change altitude doesn't work, the enable disable landing gear thing isn't going to work either. And I mean, if deposit doesn't work, withdrawal is not going to work because I shouldn't be able to withdraw if I have no balance. And again, it's not great that the unit tests aren't completely independent, but it's okay. That's what it is. We're testing our code little bit by little bit at a time. So I'm just going to copy paste and do some renaming. So I want to test withdraw. So let's say if I put in, say, $10. So and I don't actually care about the deposit result. So I can just deposit money and throw away that value. I don't care. And then I want to try withdrawing money. I want to withdraw, 6.8? So my expected balance should then be 4.2. And this will be my withdrawal result. So we'll have a Boolean withdraw result. So that should be a success. Right? It should let us take out the money, and then the new balance should update to 4.2 because we withdrew some money. Okay, and this is test withdraw with a negative value. So again, we want to make sure it doesn't change. So let's say if I put $10 in, it should stay at 10. Right, if I try and withdraw negative. This is my withdrawal result. Withdraw result. So my withdrawal result should be false if I try and withdraw negative money. And my balance should stay at 10, right? It shouldn't change the balance. Yeah, yep. That's the bad number. You're right. Not 6.2. 5.8? Yep. How about that? 5.8. It's okay, and that's why we run the tests. So withdrawing negative should be no change, and then we're going to do one more test that we withdraw, we'll say, greater than balance. So if I try and withdraw $10 and I only put in, let's try 20. Why not? So if I put in 10 and we try and withdraw 20, it shouldn't change. I should still have 10 when I'm done, and it should tell me no, false. And then I'm guessing this one here is going to be 6 because I added 3 more tests, and it seems to go last. I don't know why. Oh, it was 5. Fine, 5. They only had 2 more tests? I don't remember. Look at that. And now we get 3 passes. Withdraw negative. Withdraw greater than balance. I know I was close, right? So there are 6 tests. Okay, but that is the 5th test. I don't know how it picks it. It's silly. I'm sorry. It's whatever. Right? It's just nonsensical. All right. You guys good so far? So again, just practicing the tests here with this. But we're mixing and matching here, so bank account has that static field, which is silly. But so hopefully nothing too new here, right? So with more practice. Now what's going to get a little bit more interesting is we're going to practice using those classes. Okay, so we have some accounts, that's fine. Some math, this fun stuff. So let's make a bank account. Bank account checking equals a new bank account. Eric is the owner. Checking is the type. Okay. Then what we're going to do, given the theme of Robinhood and crazy stock meme stocks and things getting pumped up, we want to gamble with our account. Because honestly, it's not investing anymore. You're just gambling if you're putting money into some of those stocks. So let's write a function for it, our method for it. And again, we're in this Chapter 8 night class, so our functions here are static. I know AMC, I was going to buy more today, but don't take my financial advice. I'm not a financial advisor. I am gambling. I'll be honest about that. Right? We've got to be honest. So we're going to write a static method. Notice void main has always been static. Public static void main, because we don't need an instance of Chapter 8 night class. Main just gets called. It'll go back, yeah. I don't know. I put it just a little bit of money into some of those just to have some fun with it and see if we could try and squeeze. But they're down about 50% from yesterday. But no one could buy it today. So maybe if that thing gets fixed up. Anyway, so let's gamble, right? Gamble. So we're going to gamble given a bank account. I will just call it account. Doesn't matter. So inside of this method here, we're writing. Nice. Yeah, I chickened out, or I got excited. I sold my doggy coin last night. Once I hit positive, I was up like 5%, and I was sad. So apparently Elon Musk is tweeting about doggy coin again. So we'll see. We'll see if that goes anywhere. You know, that's a gamble too. It's totally made up in value. So why not? Yeah, the dip when they bought everyone, it kept everyone else out. Spinning the wheel. That's what we're going to do here. So we're going to gamble. So given this account, let's do something with it. Let's find a random number. So random equals a new random. So with random, we're using a new instance, right? This is not static because when you create random, it generates a seed value. Remember, we can give it a seed if we want to fix that value. Do you remember that from 1500? Otherwise, it just gets the system clock time. So it's a pseudo-random number. It's random enough, but I wouldn't run the lottery off a Java program. Right? It's not like a cryptographically secure random value. It's just pseudo-random. Okay? So then we'll have a double for, maybe just an int. Probably doesn't matter. Int for value is random.next. And let's go between 0 and, say, 1,000. So we want 1,001 because we never hit the max here. Okay, so randomly between 0 and 1,000, we'll do something. Now, we're either going to win or lose, so I'm going to do one more here. I'm going to say if random.nextInt 2, so that'll give me a 0 or a 1. If that equals a 0, we lose. We'll take bank account or account, and we will withdraw that amount of money. Otherwise, we'll win. We'll take our account, and we'll deposit that amount of money. And we'll give that a little format, clean it up a little bit. So this is a random 50-50 chance of win or lose this whatever random value we got. And that's it. So let's print out our checking account. And then we'll gamble with it. We'll gamble the checking account. And then we'll print it again. Oh, radius, fine. Oops, shoot, we got garbage output for print line. Remember, every class eventually inherits from object. It doesn't say it, but it does in Java. So if we want to be able to represent ourselves nicely as a string, we need to write a method. We're going to add an override method. I'm going to change the behavior of toString. So we're going to return a string, which is like our owner name, or I don't know, account account type plus the account type plus owner plus the owner name plus the balance. Maybe a $sign there, why not? And we'll go down the line, try and clean that up. Plus the balance. Sure. So now if I add this toString method, I'm going to get a different behavior. I don't want the default object behavior. I want, hey, this is a nice representation of my class as a string. And now we can gamble with it. Uh-oh. We must have lost, because it's still 0. Maybe we should put some money in it first. So let's pretend. So let's make the account, and then we'll do checking deposit. Let's put $1,000 in, right? Because that way we can possibly lose it all, or maybe double our money. We're really rolling the dice here. Okay. Hey, look, we won. We won $315. Not too shabby, right? Again, not actual financial advice. Please, please, please. Okay. We're just being silly here. Let's try it again. See if we win or lose. Oh, we lost 665. Ouch. Yeah. That's the AMC stock dropping. All right, let's try it again. Ooh, we lost only 400 something that time. Never put more money in than you're willing to lose, by the way. That's actual financial advice, right? Don't ever bet more than you're willing to lose, because you might lose it all. It's definitely a chance, especially with all the shady stuff going on. So, just FYI. Okay. So what's happening here is we are passing an instance of bank account to this method. Okay. So this checking account gets created somewhere in memory. And what Java does is it says, okay, hey, operating system, I need a place to store a string for owner name, a string for account type, an int for account number, and a double for balance. Please give me some space to store this stuff. And then our variable, checking, points to that location in memory where this thing is stored. Now, it's actually kind of fun to draw out a picture of this. Okay, so we tell Java we want a bank account. Okay, so Java says, okay, sure, x734b is where that thing is. What's stored there is a string reference for owner, a string reference for type, an int for number, and a double for balance. So the int and the double are actually stored somewhere here in memory. That's fine, right? Actual values, because those are primitive types. Primitives are stored right in that location. Strings, though, remember, are references. They're reference types. So somewhere else in memory, say like 325A is the owner name, Eric. And maybe somewhere over here like 7210 is checking. So reference types, what we're storing is the memory address of where it actually is. And what happens here, this is about 64 bits, because we're a 64-bit computer. I think that's how that works. 64-bit. That sounds right. And again, it's not actually all that important. The int here is just, what did we say? That was 16? No, 4 bytes. So that's 4 bytes. So 64 bits is just 8 bytes. So that's 8 bytes. 8 bytes. And the double here is 8 or 16 bytes? I forget. Not actually important to the thing. We're just saying, hey, here we're just going to store a value. So when I hand bank account to a function, like gamble, we just say, hey, gamble, use x734b in memory. Here's your address. I don't make a copy of anything. So that way, I'm pointing at this location. I can use get balance, I can use withdraw, I can use deposit, I can use all the functions, and they will affect the bank account stored here. What I can't do is steal their account. So inside of Gamble, if I wanted to and say, hey, account equals a new bank account, we'll say this one's owned by a hacker and it is a Bitcoin type account or something like that. Sure, why not? We can do this. But what happens here, when you use this new keyword, it says, oh, sure, new, you want a new location in memory for a bank account. at, hey, I don't know, X1137. No, the account type was a Bitcoin account. It's not a real checking account. It's just pretend money, don't worry. So what we do now is we say, oh, sure, we now pointed this one. So nothing here changes. This one still lives in memory. And when our code is done, the checking account has not changed at all. We've only changed it, and we're referencing a new location inside of this function. So now when I run it, the hacker's not going to take my money. If they withdrew my money first, yeah, they could have taken it and put it in their new bank account, whatever. So in this case, this is creating a new bank account, and account points to it. It doesn't change the old account. Okay? Old account isn't changed. So old account is still here. Okay? All right, how you guys doing so far? You all right? We're just cruising. We're cruising. Okay, cool. All right, let me take a peek. What else do we have? Nope, that's the wrong window. This one. All right. Okay, if you wanted to, the other thing we could do is return a bank account. Like with a method, like create an account, we could return one. That's, sure, we could, why not? So public static void, bank account. Something like create account. And if we give it, string for owner name and a string for account type, we can do these things. Why this might be helpful, right, is we can make a new account and then we could do something with it. Account equals new bank account, given owner name and account type. And then maybe we deposit, right? We're saying, hey, we're a bank. We want you to do business with us so we can charge you all sorts of overdraft fees. We'll give you $100 free if you open an account with us, right? That's not shady at all. They just want your business and they want to charge you fees, because banks make money off of fees lately and less off of loaning money out to people, which is kind of unfortunate. But it is what it is, right? Okay. So you can create an account. And we'll give you bonus money. So create account with bonus. With bonus. Sure. So then we can make our bank account. So instead of saying new bank account, Eric, and checking, I would say create account. Here's my name and my type. Now I have bonus money. Look at that. I got free money from the bank. Sadly, I'm the bank here, right? It's my program. Yeah, we'll stop doing this hijacking here, and we'll go back to gambling our money. Okay. There we go. Oh, we lost money again. Oh, bummer. All right, it's getting close to 7. Why don't we plan to take a quick break? We'll come back. We got a couple other topics. Wrong window. A couple other topics to tackle here. And then we'll be about halfway. We're going to look at, we did toString already. Did that one. We're going to look at equals comparison of objects and copying objects. And then actually, you guys are doing good. I spent a decent amount of time talking about Project 1 on Tuesday. So what we did this morning was this bank account example and some of these overrides. Yeah, I think we're in pretty good shape. We should be able to get mostly done a little bit before 8 for as far as we need to go, and then you'll have a little bit of time to work on Project 1 if you want to spend your time doing that. And we can go from there. All right, why don't we take 10? We'll come back. Let me put on some more music. I gotta find a better app here, but at least this one doesn't have ads like Spotify. Those are all singles. This one, there's a couple. We'll try this. Oh, I gotta crank the volume. That's right. Let me know if it's too loud or anything. I can adjust all that. Alrighty, folks, welcome back. We've got 7:08 or so. Hope you're still hanging out. Got a couple more topics to talk about. Excuse me. All right, so we're going to look at how we can compare objects to one another, right? All right, good. Glad you're still there. So what we might want to do, right, is see, hey, is this bank account the same as another bank account? Right, so maybe we're to go check in here. Let's make another account here. So let's do a bank account for checking. And we'll use our function here, right? Why not? It's another bank account. I want to see if they're this. Oh, no. So bank account's bad for this. I'm sorry. That's right, because we have unique account numbers. Let's make a new class. We're going to make a stonk class here. Let's trade some stonks. Okay, so stonks have a private string for the symbol and a private double for current value. Okay, and then we'll write a constructor that takes a string for symbol and a double for value. Okay, we'll set my this symbol to the symbol, and we'll set my this value to the value. Oops, value to the value, and give that a little format. That's nice and clean. Again, don't do more work than you need to. Let's insert some gets. Generated, awesome. All right, and then maybe we'll do that override for a toString. Oh, you know, before we do that, let's do this. Before we override toString, that's right, this is a good example here. Let's make some stonks. So let's have a stonk for GameStop. There's a new stonk, and that's GME. Right, everyone's talking about it lately. And let's see, what is their price currently? Let's see. Take a peek. Get that. Come on, let's load. Let's load it. Yeah, it's thinking about it. I don't know why it's going so slow. Maybe everyone's hitting Robinhood still. All right, 336. Nice. 336 for after hours trading. 336. Okay. So we'll put it in at 336. Okay, and then we'll make another one. Other game stonk. And we'll just copy this, right? So just for fun, let's print them out and see if we can take a peek at this. That one. And we'll print out the other one. Okay. See what we get. Let's make a radius. Right? Yep. This is what I get for all doing one example. All right. So we get this, which looks like gibberish, but this is actually a little bit useful for our illustrations here. Notice we get this at something here. This is essentially the memory address of where this is in memory on my computer. Pretty sure that's what it is. And sure, here's the package, here's the class name at this memory address. So you notice there are two different memory addresses. Let's make a stonk copy, game stonk, equals this one. Let's say, hey, it equals that one. And then let's print that one. Let's see what we get here. So when we say, hey, it equals another one, what we're going to get is an alias. Right? We're not actually making a copy of it. We're just saying, hey, here's another variable. It points at the same thing. When we use reference types, right? There it is. We get 2 at the same location. So I now have 2 different variables, other GameStonk and copy GameStonk, that both point to the same location in memory. So if I modify one, the other is going to get modified. In this case, we don't have any way of modifying it, right? We didn't give any public methods to do that. There's no change value sort of thing, but that's okay. We could go add that later. But essentially, you're in bad news here. This is bad news bears. 2 variables pointed at the same thing. And when I say pointed, I mean they are referencing the same value. Does that make sense when I say they both point at the same thing? Right? Checking on you guys in chat here. You good? Okay. So what we could do, let's do this here. Let's see. Let's check. We'll do GameStonk equals other GameStonk. I'll put all that in quotes. Let's see. Okay, so I need that as a Boolean first compare. There. Right, and we'll do another comparison with other and copy. Second compare. That's our second comparison. We're going to see, are they equal to each other? Yeah, good to go. All right, awesome. Radius. Oops, I didn't add a space there. But so GameStop does not equal other GameStonk. That's false. Copy and other do equal each other. That one's true. So what we get with this double equal sign is, are you the same location in memory? Or reference types. Same location in memory. You both point to the same thing for reference types. Okay? Do you remember doing comparisons with strings could be awkward? We might run into some weird results. So when we got to strings, we said, hey, we should use equals. So this is an equals first result and an equals second. And instead of using the double equal sign, I'm going to use the equals method. And you might wonder, well, hey, how do you do that? Well, remember, object has an equals method. Got one defined for us. All right, so we're just going to swap these in here. Swap this one in here. And see what we get. Oops, I need to put the correct booleans there. There we go. Let's run it again. All right, let's say the radius is 5. Let's see what we get. So same, false, and then true. So with the equals method, that comes from object, we're getting the same comparison. Okay, but what we could do is we can come in here and we can override that equals operation. Just so we can override toString if we wanted. Again, we didn't at this time, but we could. We're going to add an @override for public Boolean equals. Now, equals is weird. It takes an object we're going to call other. Other here. Okay? So this is comparing one object to another object. Right? Their type of object. Remember, back to inheritance, you can treat an object as its parent class. That's that polymorphic behavior you guys get. We all get. We don't need it running here. Okay? So the first thing we need to do is check, hey, is it actually my type of object? We're going to check if the other dot class get class equals this dot get class. We can compare them. Or if it doesn't equal, right, we should just return false. Right? If we're not the same type here, yeah, no good. Obviously, we can't be equal. Otherwise, Now, here's something that is a pet peeve of mine, and a lot of people do, and that's okay. Oh, I'm sorry. Before we do that, we need to have this is the type of stonk, other stonk, equals, and we need to cast other as a type of stonk. This is called casting. So we're saying, hey, treat it as it is this type, because I know it is, because I did the get class and it matches. So this won't fail. Otherwise, you could get null values and bad stuff could happen, but that's okay. So this is what most people do. They'll say if the other stonk dot symbol dot no. Dot, come on. Give it work. If other. What's going on here? Come on, Java. Did I spell it wrong? No, I spelled it right. There we go. Okay. That was weird. I think that was just NetBeans being weird. They'd say, hey, if the other symbol equals my symbol, and the other stonk dot value equals my value, we would return true. I'm going to tell you, please don't ever do this. This is just horribly redundant. You're saying, if something is true, return true. Don't do that. Just say, return that thing that is a Boolean expression. Right? This is either true or false. Don't put it in an if, return true, else false. Just return it. It's either true or false, right off the bat. Right? You okay so far? So now if we override the equals method, oops, it's even telling us, hey, we shouldn't compare strings like this. That's right, dot equals. We want to compare strings using the equals method. Man, NetBeans is so smart. Right? Let's try that. So now let's run our program and see if they're equal each other, because we're overriding the equals method. So radius, sure. All right, so we still get equal equals is false. But now when we use the dot equals method, we get true. So you always want to use the equals method when you're dealing with objects. Okay? Always use the equals method. Does that make a little bit of sense, what we're doing here? So we're checking, making sure we're the same type, and then doing the casting. Where'd it go? Yeah. So here we can check, hey, using the equals method, whether or not they equal each other. So that's the proper way to do things. Use the equals method to see if they work. All right. One last thing we're going to talk about today, and then we'll be good, is being careful how we make copies. So using that assignment operator, saying, hey, this one equals another, is not a good way to copy something. The right way to copy something is to do something called a copy constructor. So we're going to come over to stonk, and we're going to add another constructor. And what we're going to do is we're just going to copy the other's values. Okay, so take the other stonk's symbol and the other stonk's value, assign it to mine. I now have a copy. So do be careful. Strings, this is probably okay and safe because strings are immutable. But if you're making a copy of a reference type, which strings are, this could also end up with not a real copy, where the type that you have, like a property that you have, one of your attributes, if it's a reference type, it might point at the same reference of the other one. So this is dangerous. Don't use equals to copy reference types. Strings are an exception. Because remember, strings are immutable. So if you did try and change it, it wouldn't work, right? It would point to the other one at a new location, and you'd still point at the original, because strings are immutable and special. Other than that, that's okay. So now we can make copies, right, with the correct way of making a copy. So let's say this is a good way to copy after we write a copy constructor of a stonk real copy, game stonk, equals a new stonk given GameStop. So we're still using the new keyword. We're creating a new object in memory, right? The Java is going to allocate new memory for us, and we hand it the existing one we're going to go and copy. So now when we do that comparison, a real copy to this one, let's throw some of these in here for fun. Let's do, I don't know, one more down here maybe. A third compare is the compared to the real copy. Okay, and that's our third compare. And we'll do a third equals as well. Equals third compare, real copy. Okay, so the double equals should be false because it's a real copy, means we have a new object in memory. They're not going to point to the same location in memory anymore. But the equals should be correct because we made a copy of it and the values are equivalent with our equals method. What we're hoping for. Okay, so the equals is true, but the double equal sign is false. This is what we want to have happen. So remember, don't use double equals when you're doing reference types. Use an equals method, and then we have to write our own. Right? We have to tell it, hey, compare your symbol and compare your value. If those are the same, sure, you're probably the same stock. You okay so far? Cool. All right. Other questions, thoughts, concerns? There's more. We're about halfway through the chapter right now in terms of what we need to do, but we're going to finish that out next week. Yeah, I think we're in pretty good shape. Please do be reading the textbook. Mr. Gaddis has great examples. I'm trying to give you some highlights and give you other ways of illustrating some of these. I know he does use bank accounts too, but we're ever so slightly different. So that should be okay. And we can go from there. So if you don't have anything else, I've got more time to answer questions. We can talk about other projects, but you guys are in pretty good shape to keep moving here. Again, if we were in person, I definitely don't talk the entire time. I would give some examples and have you guys try them, give some examples, have you guys try them, and more of a lab time where you can use the computers and we can try some exercises and I can walk around and help troubleshoot anything that's going on. So just to set that expectation. Okay, we'll give it a format. I think we're in good shape. Let me commit this to GitHub. And we can go from there. All right, let's find 2151. It is evening, chapter 8. That's weird. None of that should have been in this folder. Did I do something wrong? Repository. Probably did something wrong. That's unfortunate. Yeah, none of... Why are those there? I should have put those in the 2454 class. I'm confusing myself, folks. Yeah, they're all there. Okay. So I'm just going to discard changes, and that will delete the file. Yes, because I don't want those. Git is fantastic. It's a wonderful tool. Discard. And that one. Come on. One more. Okay. Evening chapter 8. Great. Commit and push, so all that code's out there. Cool. All right, other questions, thoughts, concerns? How you guys doing? Okay. I got one other fun fact for you guys. I finally learned how a couple things were named. Like sometimes things in the ocean are hard to name. So when some early explorers were going around, they realized when they're in a boat, it's not land. And then when they found some land, they said, "Oh, is land." All right, that's a free dad joke for you guys. All right, so we'll take the rest of the time for exercises. Start working on the project if you haven't yet already. Again, sorry you have to give me a file. I messed it up in D2L. Next time I should remember that it's working better. Yeah, we can go from there. All right, if you guys don't have anything else, let's see. Is there anyone else around online that might be fun to go raid? Just for fun? Let's see. Who's around? Should go check out Dr. Mick. I don't know if that worked last time or not. I don't remember if we tried it. But we should. That's totally worth it. We'll see if we can raid him. Live. Yes. All right. We're gonna head over to his channel for fun. Send him our love. And Twitch. He's a great guy. Part of the Knowledge Fellowship. All right. You guys take care.